Welcome to this session. That is going to be a workshop about osfci. That is a tool which has been designed by HPE and provided to the OCP Foundation. I am Jean-Marie Verdun. I work at HPE. I'm here with Arun. So we were there last year to disclose the tool, but today we would like to teach you how to use it. I think it's something important. So what was the idea? Roughly, the intent of the tool was to fix one issue which arose during the pandemic. One of the main problems that we faced, we had to all work from home. And when you are firmware engineers, you are breaking things. And you need to use hardware just to test and validate that the software code that you design works properly. Unfortunately, I'm living in a small condo, and I had to put my hardware under my bed. And I ended up to debug system at home. And my lovely wife, who is in the room, I think today, didn't really enjoy the noise generated by one new systems at home. So as an engineer, I said, OK, let's try to fix that issue. And I started to build up a tool just to work remotely when designing firmware. And the primary issue was how to recover a server when you break it. Because when you design system firmware, mainly when it doesn't work, your system is totally unusable. And this is how osfci came up and how we started to work on it. I was not the only one to work on this project. The main goal was really to allow the firmware team just to work on from home, and it was really a critical thing. So we start from scratch, and we wanted to have something which automatized the whole firmware development workflow. So we started to work on building Docker image, which were able to build a firmware image. So we start from GitHub, and we are polling source tree. We build this source tree. If the build is failing, so that error is reported to the end user. If it is a success, we are delivering a firmware package, which can be a BMC image or a ROM or BIOS image. And that image can be loaded directly to the tool and to our target systems and can be tested. So everything can be done manually within the tool, but remotely, or can be fully automatized either through the web UI or through the API that we have integrated into it. The main goal was to target open source firmware, like OpenBMC or Linux boot. But we ended up to use it either for internal proprietary technology inside HPE, which is just great. But from the beginning, we wanted to make it an open source tool, and we did it by providing it to the OCP Foundation. So the goal of this workshop is just to show you what you can do with the tool and how can you manage firmware development with that tool. We had another talk this morning where we announced 2 OCP Experience Center for open source firmware development. One is hosted by HPE in Houston, and the other one is hosted by Scaleway in Paris area. So you can open up an account to these tools. It's totally free of charge. We are not monitoring your activity. There's no ad or whatever. So the goal is really to build up a tool for firmware developers, and this is what we are doing. Arun is going to introduce you what you can do, and then we can have a quick Q&A session.
Thanks. So I think before we go to the live demo, I just wanted to give you the rough workflow of what we'll be covering. So using the tool, you can build your custom firmware. So you can actually pull in a repository like is being shown on the slide, start a compilation process, build it and load it on the emulator, load it on the same goes to the BIOS. So you can actually do that. Or you can choose to use the default image. Same, you can go for custom Linux boot builds. Then you have the option to load the firmware. And then finally, you have to power on. So you literally power on the system with a freshly built firmware. The next one is actually pretty interesting. We are working pretty closely with the test and validation group inside OCP. So we have a bunch of tests that are coming up from the OCP community itself, and that's hosted by plugins, including Contest, which has been featured here. For those of you who don't necessarily want to use the web interface, We offer full API-based automation, so as long as you have an account with the OSFCI website, you can refer to the GitHub repository, get your sample scripts, repurpose it, or write your own, because it's all API-driven. So I think with that, I can switch to the live one. Hopefully it works. So like with all the cooking shows, I did a bit of cheating, which is I preloaded some of the things. Here you see that I built a custom image, dropped it into the system, and asked it to load it up. I did that, and then I asked it to power on. At the end of the power on cycle, you get a direct command line to the BMC shell, as you like. And you also have the option of going into the BMC web interface. So as you can see, you can access that. You can get all the server power operations, everything else for that particular system under test. The other thing that I was mentioning was the community-driven tests. So this is sort of the testing option that you can get through Contest Web, and it'll put you on this page. Right now, we have certain sample tests. It's not fully powered through the community because the specifications were very recently done, so we are rapidly onboarding that. So let's say that you want to run a particular test. You just select that, and you hit run. The internet is a bit slow. Okay. And you can also deploy your own version of the CI. So I'm actually showing you the internal version that we have running for our engineering groups. As you can see, it's got a lot more boards. So you're welcome to purpose, just like Scaleway has done, which Jean-Marie mentioned. So it also has the same features. So this is pretty much a system that you can deploy, or you can use the public instance, depending on what you want. As you can see now, the test runner is running on our system. So with that, I think I can get back to the deck.
So as we mentioned, the solution is fully open source. So you can contribute code to this to the OSFCI code. You can go on GitHub, you can fork the code, and you can issue pull requests. So the tool by itself is mainly focused on building a firmware image, testing it, loading it to live hardware remotely. You can do that from an iPad or from any kind of tablet or laptop. That's the main goal. But enhancing it is really critical. We don't want the tool also to be fully dedicated to HPE, so that is also why we contributed it as a general purpose tool. It is targeting BMC and it is targeting ROM. The architecture of the tool is fully modular, so we have a lot of building blocks into the source tree. We think it's easy to understand, but it is written in Golang, so you need to know Golang just to understand how the tool works. That is an easy to learn languages, but you still need to have that asset. The automation is built on frameworks. So right now we are using Contest from Meta. We are thinking about integrating robots also, and enhancing the non-interactive mode. So the API endpoints are supporting all the web UI features. The main reason behind that is that the web UI is just a graphical interface to the API endpoints. We are also trying to enhance logging and analytics. And what is critical to us is just to be able to test as much hardware as we can, because open source firmware will be a success only if it could be cross vendors. So we are seeing more and more demand around OpenBMC. But this demand is driven from the fact that these end users are really expecting to run the same OpenBMC image between vendors. And that's about the same thing from the ROM. So we need that abstraction layers which is starting up the hardware on the BMC side and giving the opportunity to the end users to plug in their own very, I wouldn't say secret sauce, but their own features which are required for their provisioning systems mainly. So OSFCI is using a very open license. That's an MIT-based license. So you can do whatever you want with the code. And if you want to internally use this tool, you can do that without even referring to the community. So there's no constraints, roughly. So I soon spoke about the architecture, but the magic behind it is based on the fact that we are using Flash emulators. So if you want us to integrate some hardware within one of the OCP experience centers, so we'll be needing to modify the hardware, or you will be needing to send us hardware with the pin headers on the SPI interface, so including the BMC and the ROM. And if you are using, I would say, high-level security stuff, we'd love to have unlocked hardware, which will be used as development purpose hardware, because it's way much easier just to develop firmware on this kind of hardware. So we do not do any kind of emulation or virtualization. So there's no QEMU behind that. Everything runs on real hardware. And we believe it's critical, especially when designing firmware. The main reason is because it's pretty tough just to design a full QEMU model of a modern motherboard. So we got many components, including CPLDs and host, and all these kind of components are very hard to modelize into QEMU. So it's easy just to modelize the BMC ASICs, but all the environment around it, it's pretty hard, and we don't want to spend more time on trying to make it work. So because we have an hardware solution which is, we believe, a good one currently. So for the diagnostics, we are currently studying multiple frameworks, and Arun is going to introduce them.
So this is actually credit to the excellent effort from the community with the test and validation group. So this is being under active development, and it has started the release process. So the diagnostic framework provides, again, a simple API available in C++ and Python to create diagnostics that can be easily integrated with test platforms, including ours. So as you can see, one of the plugins is Contest. As you can see that the CI is already showing you that. So all the tests in this particular format will work across vendors, design partners, manufacturer, and hyperscalers. So this actually provides portable reproducers for qualification issues. So I think this is a very, very significant step by the community, and we are really excited to be a primary vehicle for that with OCP's instance of the OSFCI. And as you can see, you have the use cases within the diagnostics. So ranging from hardware bring up to system integration testing to reliability testing, manufacturing, data center operations, and reverse logistics, RMA, et cetera. So the vision is that within a couple of months, you'll start to see those test population, the options rising in the CI tool as we start publishing more tests. And of course, this is going to be a collaboration between all of the companies like Meta, Google, Microsoft, HP, and all of that. So we're super excited about that. I think this is the right direction. What's the call to action? So you can get your account for the tool on the US website, which is the OCP.tech, and the European website, which is going to launch within a couple of weeks, which was already announced earlier this day. You can also make your own instance. You can go and fork the tree, which is very easy to do. You can study the API examples if you want to run things without necessarily interacting with the web console. And of course, if you want to check out more of the excellent work that's been done by the test and validation group and the community, you can go and check out the community tests that will be populated at the OCP Diag core. And of course, we actively invite open contributions through pull requests, feature requests, and of course, participation through the OCP framework. And thank you so much for your time. We now open it up for some questions.
Thank you. Is there any questions?
So what project is this work being done under?
It is done under the OSF project, the the open system firmware project within OCP. So which is targeting currently only system ROM, but I'm under discussion with the foundation to expand the footprint of this project to firmware instead of focusing only on the system ROM.
Right. So if I have to point somebody from my organization to this this team that's working on it.
Yes, you need.
How do I point him?
Yeah.
How do I? Where do I point him to? That?
I think within the call to action, you get the GitHub entry. So the GitHub repo is probably the easiest way to get in touch with us. So they just open an issue or whatever. So we'll be receiving automatically an email, and we can get in touch with that way.
Okay, sounds good.
And I will also send you a follow-up.
Fantastic. Thank you.
Any other questions? We'd like to thank you and hope you enjoyed the rest of your day. We will be on HPE booth and within the Experience Center, as this is a community project, where Arun is running live demo of the tool. And if you have further questions or ideas to enhance the tools, just feel free to come by and entertain the discussion. Thank you.